Hello everyone, welcome to the course in operating system. I, Rafiqul Islam, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology under the GIS group. In lecture 10, that is in previous lecture, we have discussed up to first come, first served scheduling algorithm, FCFS algorithm. And we have seen that in that algorithm, we have a problem that is called convoy effect. So in this case, the average waiting time was very much. Okay. So now in this lecture 11, basically we are going to start the another process scheduling algorithm. This is called shortest job fast algorithm. So our next scheduling algorithm, this is nothing but shortest job fast algorithm, or shortly we can write it SJF algo. SJF, shortest job fast, or sometimes we can call it shortest job next. So here we have to schedule next whose bus time is minimum shortest. Okay, so here the basic important point is shortest job means how we can identify a shortest job. So basically bus time. So shortest job means whose bus time is minimum, right? So this is called shortest job. And in this particular scheduling algorithm, suppose in ready queue, this is our ready queue or ready state. Suppose in ready state we have a process P1 whose bus time say 5 unit, and suppose we have another process P2 say whose bus time 6 unit, say another process whose bus time 3 unit, and suppose we have another process P4 whose bus time say 9 unit. So in ready queue we have 4 processes. So one of them we have to choose for execution, right? So here we can see that the minimum bus time actually the process P3 with bus time 3 unit. So this P3 actually called shortest job. So obviously in this particular situation we have to schedule P3 first. Then we have to schedule P1. After that we have to schedule P2, and at last we have to schedule P4. So this is actually shortest job first algorithm. Okay, so here we have to choose a process whose burst time is minimum. Okay, now here the scheduling criteria. So here the scheduling criteria is burst time. The process having the smallest CPU burst, CPU is assigned that process. Okay, and here the important point is, and if two process having the same burst time, if two process having the same burst time, then we have to use the arrival time, that is FCFS algorithm, to break the tie. Okay, so to break the tie, we have to use the arrival time, and if arrival time is also same, then we have to use the process number to break the tie. So process having the minimum number, that process we have to schedule first. Okay, so the first technique to break the tie actually arrival time. Using arrival time we can break the tie, and if the arrival time is same, then we have to use process number. Okay, so this is the tie breakers, arrival time and process number. Okay, now the next point, that is mode. Mode means actually this algorithm non-preemptive or preemptive. So basically shortest job first algorithm either non-preemptive or preemptive. Okay, so this algorithm can be either non-preemptive mode as well as preemptive mode, right? So maybe non-preemptive mode or maybe preemptive mode. But basically pure SJF, which we can say that it is a non-preemptive algorithm, and the preemptive version of SJF, sometimes it is called shortest remaining time first algorithm. Okay, so the preemptive mode of SJF algorithm is called shortest remaining time first algorithm. So here the non-preemptive actually SJF, and preemptive, that is called SRTF. Okay, so I think this point is very much clear to you. Non-preemptive SJF and preemptive SJF, which is called SRTF. So in this particular section we have to discuss SJF, that is non-preemptive mode, and again we have to discuss the another algorithm, that is preemptive SJF or SRTF. Okay, so now the next example which I am going to show, that is non-preemptive SJF. So this is an example, and this is actually non-preemptive preemptive SJF. So in this example, given some processes arrival time and burst time. Okay, so this is our processes arrival time and burst time. So please take a note. So this is actually given in your numerical problem. This is given. Suppose this is P1, P2, P3, P4. There are 4 processes, P1 to P4. And also arrival time also given. And suppose this is 0, 1, 2, 3. And burst time also given. This is for 5 unit for P1, 3 unit for P2, 2 unit for P3, and 6 unit for P4. This is also given. And now in this particular problem, we have to calculate the average turnaround time. So here we have to calculate average turnaround time, TAT, average waiting time, WT, and average response time. And at the same time, we have to calculate throughput. So these 4 points which we have to calculate using this given data. So using this given data, we have to calculate average turnaround time, average waiting time, average response time, and throughput of the system. So now, in order to calculate this point, at first we have to draw a schedule chart, or this is called Gantt chart, right? So the drawing of schedule chart is most important in this particular point, right? So now how we can draw the schedule chart using this data. So this is the chart starting from 0, the chart which is starting from 0. So now check. So there are 4 processes in this particular given data, and the shortest job actually P3, because whose burst time actually 2 minimum. But at the same time, we have to check the arrival time also. So when that time is 0, then in ready queue we have only one process, that is P1, because the arrival time of P1 is 0. So in time 0 there are only one process in ready queue, that is P1. So obviously, forcefully, or there are no option to choose any other process. So obviously at first we have to choose P1. Okay, so here we have to schedule P1, and as it is non-preemptive scheduling, so we have to schedule it for 5 time unit. Okay, now when time is 5, then in ready queue we have 3 processes, that is P2, P3 and P4. When the time is 5, then in ready queue we have 3 processes, P2, P3, P4, because the arrival time of P2 is 1, arrival time of P3 is 2, and arrival time of P4 is 3. So in ready queue we have 3 processes. Now check among these 3 processes which one is shortest, that means whose bus time is minimum. So here we can see the minimum bus time of process P3. So next we have to schedule P3 for time unit 2. So the next time bound should be 5 plus 2, that is 7. Okay, so now the remaining processes in ready queue, that is P2 and P4. So P2 and P4, compare their bus time. So here the minimum bus time actually P2, that is 3. So next we have to schedule P2 for time unit 3. So this bound should be 7 plus 3, that is 10. And the last process in our given data, that is P4. So next obviously we have to schedule P4 with time unit 6. So it will be P4, and the time bound here should be 10 plus 6, that is 16. So this is your schedule chart using this given data. Now here we can calculate various process related parameters, right? So here first we can calculate, this is we can call starting time, ST. Another which we can calculate, this is finished time or completion time, FT. Next we can calculate here turn around time, TAT. We can calculate here waiting time, and also we can calculate here response time. Okay, so these parameters which we can calculate using this schedule chart. Now how? See, actually starting time which we can calculate directly from this chart, starting time which we can calculate directly from chart. Here we have no formula. So now see the starting time of P1, actually this is the starting time of P1. So here the starting time of P1 nothing but 0. Okay, now the starting time of P2, so this is the starting time of P2. So this is nothing but 7. So starting time of P2 is 7. Now for P3 it is 5, and for P4 it is nothing but 10. So these are the starting time for P1, P2, P3 and P4. Now finished time. Also, we can calculate it using this chart. So from chart, directly from chart, we can calculate it. Okay. So here the finished time of P1, that is 5. Finished time for P2, that is 10. Finish time for P3, that is 7. This is the finish time for P3, that is 7. And finish time of P4, this is nothing but 16. Okay. So this starting time and finish time or completion time, we can write it directly from chart. Okay. Once you can design this chart, then you can write the starting time and finish time direct from this chart. Now, turnaround time. So basically, in case of turnaround time, we have a formula. So turnaround time actually nothing but finished time minus arrival time. So this is your turnaround time, finished time minus arrival time. Okay. So now use this column and this column, right? So you can easily calculate this turnaround time. So finish time for P1 is 5, arrival time for P1 is 0. So turnaround time for P1 is nothing but 5 minus 0, that is 5. Now for P2, it will be 10 minus 1, that is 9. For P3, it will be 7 minus 2, that is 5. And in case of P4, it will be 16 minus 3, that is 13. Okay. Now, what for waiting time? So in case of waiting time, we know the formula, that is starting time minus arrival time. So in case of waiting time, we can use starting time minus arrival time, or also you can use turnaround time minus burst time, right? So basically here we can use starting time minus arrival time or turnaround time minus burst time. Okay. So actually if the algorithm is non-preemptive, then we can use starting time minus arrival time or turnaround time minus burst time. But my suggestion is, if the algorithm is preemptive, then better you use turnaround time minus burst time, second formula. For preemptive algorithm, it is better to use turnaround time minus burst time to calculate waiting time. Okay. So in this particular case, if we use this formula, then the waiting time for P1, it will be 0. For P2, it will be 6, that is starting time minus arrival time. Then for P3, it will be 3, and for P4, it will be 7, right? So just put the value and calculate. So this is called waiting time. Now for response time, actually response time, it is actually fast response minus arrival time. So as you know that in case of non-preemptive algorithm, the waiting time and arrival time always should be, waiting time and response time always should be equal. So here the response time should be 0, 6, 3, 7. In case of non-preemptive algorithm, waiting time and response time always equal. So this is the situation, right? So here we have to calculate the average turnaround time. So please average this. So here we have to calculate this 3 average value, right? So the average value of turnaround time, that is 13 plus 5 plus 9 plus 5, I think 18, 23 plus 9, 32, 32 by 4, that is 8. In case of average waiting time, this is 7 plus 3 plus 6, that is 16 by 4. This is nothing but 4. And also the response time, also average response time should be 16 by 4. This is also 4. Okay, so this is the average value. This is the average value, and this is also the average value, and this is also the average value. And now for throughput, actually throughput, we know that throughput actually total number of process executed per unit time. So here total number of process, that is 4 by total time. We can see in case of this chart, the total time is actually 16. So this is 16. So this is your throughput. Okay. So this is actually non-preemptive SJF algorithm. I think this problem is very much clear to you. Okay. So now in this non-preemptive SJF, basically here the throughput is maximum. Here the advantage is actually maximum throughput and minimum average waiting time and turnaround time. So here the throughput is maximum, waiting time and response time is minimum. So I think this is a good algorithm. Here throughput actually maximum, waiting time minimum, turnaround time also minimum. So it is basically good algorithm, efficient algorithm. But here the problem is it is not implementable, because burst time of process cannot be known ahead. So how we can say the burst time of process P1 is 5 unit, burst time of process P2 is 7 unit, etc. Okay, so this is impractical actually. And here starvation problem exists. Okay, so starvation for longer process. So as in terms of efficiency, it is a good algorithm, but we can't practically implement it because burst time of process cannot be known ahead. Okay, so this is all about your shortest job first algorithm. Okay, now in case of this shortest job first algorithm or burst time, so there are some prediction mechanism through which we can guess the burst time. So here we have some prediction mechanism to calculate, to guess the burst time. So this is actually nothing but prediction technique. Burst time prediction technique, right? So we have static technique and Another is dynamic technique. Okay, these techniques are not in our syllabus, so I just say few words on this technique, not in details. Okay, so inside the static unit we have a technique. This is called process size. Process size, and another technique which is called process type. Process type. And in this dynamic method we have simple averaging, and second technique which is called exponential averaging. Exponential averaging. So these techniques through which we can guess the burst time. Okay, so in case of process size, depending upon the process size we can guess the burst time. Okay, suppose for a old process, for 200 kb, so suppose burst time 20 unit, right? So we can say that for a new process up to 2200 kb, the burst time may be 20 unit. So this is actually process size. And in case of process type, according to different process we can say the burst time. Suppose operating system processes like scheduler process, etc. Here we have 3 to 5. So operating system processes, for operating system processes we have 3 to 5 unit. Interactive process 5 to 8 unit. Foreground process 10 to 15 unit. Background process 15 to 20 unit, etc. Right? So this is just guess, right? But this is actually not real. So that's why this shortest job first algorithm actually impractical. We can't practically implement it. Okay, so this is all about the shortest job first algorithm. Okay, so now actually in our next lecture we have to discuss the preemptive version of SJF, that is shortest remaining time first algorithm. So in this lecture up to shortest job first algorithm. So thank you for watching. See you in the next video, that is shortest remaining time first algorithm. Thank you once again.